All right, so let's take a look at how we're going to calculate the pH at intermediate points within the titration. All right, so let's start out with an easy one. Strong acid, strong base. So it's basically a stoichiometry problem because, remember, it's going to completion. We're making a salt of the conjugate, but remember that conjugate, if it's a strong acid, strong base, that salt, both parts of it are going to have negligible effect on the pH. So, okay, so an easy way to do this is to look at what it is that's reacting and make a table. Since it's a strong acid, strong base, we're going to do multiple ones of these. Let's just make a table to help us with the stoichiometry. So the thing I care about are the hydroxide and the H+. That's what's reacting here. What color am I at? Okay. So here I have a table, and I took the concentration of the strontium hydroxide, and then times 2 would give me my hydroxide. So these are moles of hydroxide. That's going to stay the same. Here's the moles of the H+ is going to be based on the intermediate values that I'm adding. All right, these are going to react 1-to-1, H+ to OH. Okay, I've already taken care of the 2 hydroxides in calculating this moles here. All right, so all we need to do here is look at which one's limiting. They're going to react 1-to-1, and then my initial minus the amount that's used is going to give me my excess. All right, so if I have no H+ added from the hydrochloric acid is the initial one. All right, so my OH initially is just going to be 0.016 moles over 0.08 liters, so that's going to be 0.2. So that gives me a pOH of 0.7, which means my pH is going to be 13.3. Okay. Now in the second one, this was A from that previous slide, and then B, C, D, E. Okay. Here, again, I've added 0.008, so 0.008 moles of the H+ will neutralize 0.008 moles of hydroxide, which will leave me with 0.008 moles of hydroxide. And I added 20 milliliters, 20 milliliters of the H+ here, of the HCl. And so here, my new total volume is 100 milliliters. So again, the hydroxide is still what is contributing to the pH, and so now I have 0.008 moles now in 0.1 liters, so it's going to be 0.08 molar. And let's see, so 0.08, so it's going to give me, again, a pOH is 1.1, which means my pH is going to be 12.9. Okay, and then we go down through the same thing. Now here I've added more HCl. Okay, so 0.012 will interact with 0.012. I still, though, haven't reached the equivalence point. So now I have 0.004 moles of hydroxide, and that's in, now I have 0.110 liters, so that's 0.036 molarity. So that gives me a pOH of 1.44 and a pH then of 12.56. Okay, now here we have equal moles, which means I have no excess, which means my pH is going to be 7. Strong acid, strong base. At the equivalence point, the pH will be 7. And that's why I don't have any excess of either at that point. Now, let's go, we're going beyond the equivalence point. So now 0.016 of my hydroxide is neutralized 0.016 of my H+, which leaves me with 0.016 moles of H+ this time. So now my H+ concentration is going to be 0.016 moles over 0.160 liters. Gives me a pH, or a hydrogen concentration of 0.1 molar, which gives me a pH of 1. So again, for strong acid, strong base titrations, it's basically just a stoichiometry problem, and then you look at how much of the excess, either H+ or hydroxide that you have, and use that to find your pH. Again, taking into account that if the thing you're titrating with, if you're adding a solution, that you've got to adjust the total volume. You'll have a new total volume each time.